Alright, so this video is about the concept of pressure. Okay, a lot of students who are new don't understand what exactly is pressure, and this is useful for both physics and chemistry if you are new to class 11th. Okay, now if you first of all, the pressure is basic definition which you would have learnt in class ninth. Pressure is F upon A. So force per unit area, right? Force per unit area. The units of pressure are Newton per meter square. A lot of people write it as pascal also, right? So one and the same thing if you see PA or Newton per meter square. Now, what is most confusing to student is the concept of atmospheric pressure. Atmospheric pressure. Now, you know, atmosphere actually is nothing but the air which surrounds Earth, right? Now, you would have seen when you do physics or chemistry in class 11th, in the chapter number first, which is basics of chemistry, you do see this 10 raised to power 5 pascal or 10 raised to power 5 Newton per meter square value associated with atmospheric pressure. So it is said that the atmosphere exerts a pressure of 10 raised to power 5 Newton per meter square. The logic is that Earth's gravity, okay, Earth's gravity exerts force on air molecules, okay, which means if you have, very strictly speaking, if you have a 1 meter square column, okay, so this is 1 meter square and it is, okay, like this. I'm drawing this is your ground, Earth. This is 1 meter square. A 1 meter square column, the air which is contained in it, okay, the amount of force it applies on you is 10 raised to power 5 Newton. And this air is applying force on you because it is getting pulled by gravity. So it has a force on itself which you feel because it is downward. So atmospheric pressure is 10 raised to power 5 Newton. Every meter square will experience this much force, which is around 100,000 newtons per meter square. Okay, and the the way you measure this is also to be understood. So one is, of course, the Earth, you know, has gravity. Second, thing you must understand is, and this is very important, is if you want to measure this pressure, you know, you will not have 1 meter square. How do you do that? So what you do is you keep a container. Okay, and fill this container with a lot of mercury. Okay, fill this with mercury. Okay, let me draw a bigger container. So I'm drawing a bigger container, and this bigger container is made up of not made up of, this has a lot of mercury inside it. Mercury, okay, mercury which is Hg. And what you do then is you put a tube in it which is inverted. Okay, this is a tube which you put inside it. What you will notice is that this mercury, and mark some, you know, points on it. Maybe this tube is around some few centimeters. What you will notice is that the mercury, once you insert the tube, starts rising. Okay, and it rises to a certain point, maybe it raises to a certain point, and then it stops. Why does it stop and why did it raise? Remember that the mercury which is here, okay, you filled it with the mercury, the whole this container, this is being exposed to atmosphere. So you have atmosphere here. Okay, all these places have atmosphere, and the atmosphere is we just learnt, has the capability to exert force. We measure it on per meter square basis, and we know this much force gets applied. So this container also is facing the same pressure, which is this. Once this mercury is facing pressure, the mercury then has no space to inside the container, and then what it happens is it goes towards this side and then it stops, which means the height of the mercury here, which you see above the container, that height is able to balance this pressure. Okay, so this pressure which is measured is that 760 millimeters of mercury, okay, are able to balance this much pressure. Obviously this is in millimeters. We will convert this to newtons and per meter square basis, but the pressure which was coming from atmosphere on the mercury inside the container, it resulted in mercury going up, and it stopped because at this point this pressure from the atmosphere, got balanced with the height of the mercury. So mercury is a liquid, right, and it rose to a level of 760 mm. It also has a pressure which it is capable. It also has a, just like atmosphere, this is the atmosphere. I have drawn a column, right, this circular column I have drawn. Similarly, mercury tube is also like a column, and it has a height, and the pressure due to a liquid at a height h is rho g h, where rho is the density of mercury. You can put it as 13.6 into 10 raised to power 3, one of the most dense material, into 9.8 into h, which is 760 mm. Let me convert it to centimeters and then meters, right? The total, this becomes 0.76 meters. And if you calculate this, this will actually come out to be 10 raised to power 5 Newton per meter square. So what you're doing is you are exposing mercury to atmosphere, and it rises till 760 mm, and we say that the height of this mercury is the atmospheric pressure. So this is the way we measure the atmospheric pressure. You can change this liquid. You don't need to use mercury, but mercury has an advantage that because the density is very high, so the height to which it rises is low. If you use a low density material, for example, this is 13,600. If you use water, for example, then water will have to go very high in the column. Maybe the water goes up and up. Water's density is only this much. And if you don't have this mercury, then this height will go up drastically by a factor of 13.6, which was coming from mercury's density. So we don't use water or other liquids for building instruments to measure these barometers, for example, pressure measuring instrument. But this was the crux. If you're studying numerical on chemistry, where you have to use Boyle's law, P1 V1 is equal to P2 V2, then the pressure is coming from some source which you need to understand. And this was case of atmosphere, right? Atmospheric pressure. Earth is exerting gravity on it, and therefore you face that pressure. But obviously when the gas is enclosed in a container, it has a random motion, and it is striking the container, and that striking the container is producing the pressure. Okay, so you must understand the concept of atmospheric pressure. I don't want you to focus currently on this, which is more of kinetic theory of gas chapter in physics. You will learn later, and maybe some of it in chemistry. So I hope your doubts on this 10 raised to power 5 is taken care of. So if you're given in a numerical standard temperature pressure, the standard pressure is 1 atmospheric pressure, which is what you and me both face when we are in open. And obviously if you go inside the sea, this pressure will go up, because then the liquid above you will apply more pressure on you. But this was the concept of atmospheric pressure. And why the value is 10 raised to power 5? Because on measurement using mercury, we find that it rises to a certain level, and if you calculate that, you can measure how much pressure the atmosphere was applying on mercury by just having a very little height gain. Otherwise, you would need to build a very long instrument if you use a low density fluid. So thank you very much. I have 2000 videos on this channel and keep on bringing a lot of interesting stuff for you. Don't forget to subscribe, and thank you very much for watching this.